Hi, this is the Science Chef. You're welcome to the first part of a series on the correction to the 2024 WASSCE Chemistry Theory. In this video, we'll be providing the correct answers to the questions in Section A. If you want to know how you fared in your exams or you're preparing for any O-level chemistry examination, then join us and let's ride. So Section A, you are told to answer all the questions in this section. This section contains 10 questions, A to J. It's always compulsory, right? You are told that no marks will be awarded for answering questions not specified. We're like, okay, of course, that's WAEC. WAEC is meant for West African countries, right? Nigeria, Gambia, Sierra Leone, Ghana, Liberia, yeah. So each section, especially Section B, has country-specific questions. So that's what they are trying to tell you there, that if you answer questions not specified for your own country, you will not earn any marks there. So now credit will be given for clarity of expression and orderly presentation of materials. Answer all the questions in this section. 1A, what is an electrochemical cell? This is definition. Definition will carry 2 marks. An electrochemical cell is simply a device that converts chemical energy into electrical energy, right? It converts chemical energy into electrical energy, or a device that generates electricity through chemical changes or using chemical reactions, specifically redox reactions, to generate what? Electricity. And why is it redox reactions? Because oxidation and reduction are involved in the reactions inside the electrochemical cell, right? Oxidation occurs at the anode, while reduction occurs at the cathode. It is the transfer of those electrons from the anode to the cathode that leads to the flow of current. Okay, so let's write. An electrochemical cell electrochemical cell is a device that converts chemical energy into electrical energy, right? Or a device that generates electricity using what? Chemical changes or chemical reactions. All right. So let's look at the next question. Fine. State 3 differences between an electrochemical cell and an electrolytic cell. An electrolytic cell is the opposite of an electrochemical cell. While electrochemical cell converts chemical energy into electrical energy, electrolytic cell converts electrical energy into chemical energy. How? Electrolytic cell uses electricity to bring about the decomposition of a compound into its constituent elements. Whereas in electrochemical cell, it makes use of the changes or the reactions, chemical changes or the chemical reactions inside the cell to generate electricity. Both of them make use of the application of redox reactions. So for differences in electrochemical cell, one converts chemical energy into electrical energy. This one converts electrical energy into chemical energy. Or uses electrical energy to bring about a chemical change. In electrochemical cell, the anode is negative, whereas in the electrolytic cell, the anode is positive. The anode is the electrode at which oxidation occurs. Electrons always flow from the anode to the cathode. In the electrochemical cell, the cathode is positive, whereas in the electrolytic cell, the cathode is negative. That is where the positive ions, the cations, migrate to. In the electrochemical cell, there's the presence of a salt bridge. Whereas in the electrolytic cell, you don't need a salt bridge. In the electrochemical cell, we make use of the word voltmeter to measure the potential difference. Whereas in the electrolytic cell, we make use of the word power supply. Of a DC direct current power supply. So you don't make use of a voltmeter in the electrolytic cell. Rather, we make use of a direct current power supply, because that's what supplies the electrical energy that is used to bring about the decomposition of the compounds, right? So any of these three would be correct, right? Okay, let's move to the next question. Explain briefly what would be observed when powdered zinc is added to a solution of copper 2-tetraoxosulfate 6. Now, when you have questions like this, the first thing I will also advise you to do is to write out your equation of reaction, because when you write out your equation of reaction, it will give you an idea of the expected observations, right? So here, powdered zinc, that's Zn solid, powdered zinc, Zn solid, plus a solution of copper 2-tetraoxosulfate 6, that's CuSO4 aqueous, right? Giving us what? This will give us what? ZnSO4 aqueous plus Cu what? Solid. How do we get this copper 2-tetraoxosulfate 6? Copper 2, Cu2 plus tetraoxosulfate 6, SO4 2 minus. So this is 2. When they exchange the radicals, it becomes Cu2 SO4 2. Now this SO4 is acting as a unit, so it's a radical. So they exchange the valencies, sorry, not radical. So SO4 is acting as a unit, it's a radical. So since the valencies are the same, they will cancel out, leaving us with what? CuSO4. The same thing is applicable to this zinc SO4, because zinc has a charge of what? +2. So this is what happens. What's the color of copper 2-tetraoxosulfate 6? It is blue, while this one is what? Colorless. This is colorless solution. This is blue solution. Now, what is the color of copper? Copper is a reddish brown solid. A reddish brown solid, or a brown solid, anyone. Right. Zinc is somewhat gray solid. So how will you know that a reaction has occurred here? The gray solid will do what? Dissolve, right? Or disappear, right? And when it disappears or dissolves, what happens? It goes into the solution to form zinc ions, which then combines with the SO4 2 minus to form ZnSO4. So what happens? Zinc goes into solution, displaces the copper 2 ions from the solution, right, as copper metal. Now, the blue color of this solution is due to the presence of the what? Copper 2, this copper 2 ions here. So because the copper 2 ions are removed from the solution as copper solid, what happens? The color of the solution gradually does what? Fades. Are we together? So when the color of the solution fades, it turns what? Colorless, when all the Cu2 plus have been what? Removed from the what? Solution. Meanwhile, the copper metal that has been displaced will now be seen as a reddish brown deposit, right? So what are our observations? How many observations can we see here? We are not told to state our observation. We are told to explain briefly what would be observed. Yeah, so the zinc metal or the powdered zinc, whichever one, dissolves in the CuSO4 solution, right? And then what happens? The blue color of the solution turns colorless. And why is that so? This is due to the displacement of the copper 2 ions from the solutions by the zinc metal, right? So what then happens? Reddish brown deposits of copper, reddish brown deposits of copper metal would be what? Would be formed. So this is due to the displacement of copper 2 ions from the solution by the zinc metal to form what? Zinc tetraoxosulfate what? 6. Okay, what's the next question? Write an equation for the reaction in 1C. This is 1D, DI. What is the reaction in 1C? Let's check. Okay, this is 1C. Explain briefly what would be observed, blah, blah, blah. Can you see, we've already written the equation here. So this is the equation they expect us to write. So let's copy and paste. Zn solid plus CuSO4 aqueous, giving us what? ZnSO4 aqueous plus Cu solid. Now, let's go back to this question. Why is zinc able to displace copper here? Because zinc is more reactive than copper. Zinc is higher than copper in the electrochemical series, right? Or in the reactivity what series. Any metal that is higher than another metal in the reactivity series will always displace the lower metal from its what? Solution. Are we together? So zinc is able to lose electrons to copper 2 ions, which became what? Reduced to copper metal. So zinc was oxidized, so zinc is oxidized, while copper 2 ion is what? Reduced to copper, right? That's just the simple chemistry. Okay, so this is the equation of reaction, right? So for this, for the correct reactants and correct products, that's 1 mark. And for balancing is also what? 1 mark. Get your 2 marks there. But if you are not sure of the state symbol, please don't add the state symbols. Leave it blank, right? Then state the type of reaction which took place in 1C. Yes, you all know the answer, right? That is what? My part seems not to be working. So let's do this. So what's the type of reaction here? That's a displacement reaction. So that's the answer to that. Let's move. Next question says, name 2 gases which should be prepared in a fume chamber. What's the fume chamber used for? Fume chamber is an equipment used for preparing poisonous or toxic gases in the laboratory. And examples of such toxic gases are chlorine, ammonia, sulfur 4 oxide, sulfur 4 oxide, sulfur oxide, etc. So just name them: chlorine, ammonia, sulfur oxide, hydrogen chloride gas. Those are all what toxic gases, which should be prepared in the fume chamber. You also have nitrogen oxide and the rest of them. Okay, then give 3 factors that favor cracking. What is cracking? Cracking is simply the composition of long chain or high molecular mass alkanes, right, or hydrocarbons into smaller and more useful low molecular mass alkanes, right, through heating. And most of it's always carried out at very high temperatures. You have 2 types of cracking. You have thermal cracking and you have catalytic cracking. In thermal cracking, you apply heat at a temperature above 1000 degrees Celsius, whereas in catalytic cracking, you use both heat and catalyst, but the heat applies at a reduced temperature. Now, cracking occurs in the presence of high temperature, high pressure, and catalyst. So those are 3 factors that favor cracking: high temperature, high pressure, and the catalyst. So these are the 3 factors that favor cracking, right? And most times the byproduct of cracking is always what? It's most times, not always, it's most times the byproduct of cracking is alkenes, right? Or is an alkene. Remember, you are moving from a high molecular mass alkane to a lower molecular mass alkane that is more useful, right? Like petrol, moving from maybe a naphtha or a diesel to a petrol, right? With the formation of an alkene like butene, ethene, propane, and coal as a byproduct, which is used in the petrochemical industries. But I have to give the reason why noble gases are inert. Why are they? What are noble gases? Noble gases are simply group 8 elements. They're also called rare gases. Why are they in group 8? They are in group 8 because they have completely filled outer shells. Don't say it because they have octet configuration or octet structure. Not all of them have octet structure. Helium does not have octet structure. Are we together? Helium has duplet structure, whereas others from neon to xenon, radon, have octet structure, right? That they have 8 electrons in the outermost shell. Apart from helium that has 2 because it has only 1 shell. All right. So give reason why noble gases are chemically inert. Noble gases are chemically inert because they have a completely filled outer shell. But they have completely filled outer shells. So they have completely filled outer shells, right? Next question. State 4 properties of a homologous series. Wow. What's a homologous series? This question is from organic chemistry, right? Introduction to organic chemistry. Okay. What is a homologous series? A homologous series is a family of organic compounds that follow a regular structural pattern in which successive members differ in their molecular mass by a value of 14, or in their molecular formulae by the CH2 group. That is the definition of a homologous series. Examples of homologous series are the alkanes, the alkenes, the alkynes, and co. Now, what are the properties of homologous series? What makes a group of compounds to be considered as a homologous series? 1, right? They have what? Homologs, that's members of the homologous series. Homologs have what? A general formula. They have a general formula. 2, they have a general method. They have what? Yeah, a general method of what? A general method of preparation, which means that members of the same homologous series have the same method of being prepared, like alkanes. The way you prepare methane will be the same way you prepare ethane and propane and coal. Now, it may not be exactly the same thing, but the method used will apply to all the members, but the difference will be in the reactants, specific reactants that will be used. Like the alkanes. The alkanes are prepared by the reaction of sodium alkanate with soda lime in the presence of heat. Are we together? So now, depending on the specific alkane that you want to produce, the difference would be in that word, sodium alkanoate. If you want to prepare methane, use sodium ethanoate. If you want to prepare ethane, you use sodium propanoate. If you want to prepare propane, you use sodium butanoate, just like that, right? Then the third one here, they exhibit similar chemical properties. Please, they don't exhibit the same chemical properties. They exhibit similar chemical properties. And why is that so? So why do they exhibit similar chemical properties? They exhibit similar chemical properties because they have the same functional group, right? They all have the same functional group. Then the fourth one is that they show a gradation in their physical properties, right? Which means that as you go down the series, there will be, let's say, an increase in boiling points. There'll be increase in boiling point and melting point, because as you go down, you move from gas to liquid to solid. That's a form of what? Gradation, a steady gradation in their physical what? Properties. Then another one would be what? From the definition of the homologous series, you can get two characteristics there. You can say successive members differ in their masses by in their molecular masses, not in their masses, in their molecular masses by a value of what? By a value of 14. Yes. How? You can say that they differ, successive members differ in their molecular formulae by the CH2 group. That's the methylene group. So any four of these are what? Correct, right? Okay, so let's move on to the next question. Before we move on to the next question, please, if you are joining us for the very first time, you know that you're obtaining any value, kindly subscribe to this channel, hit the like button and turn on your notification bell to stay updated when we'll be publishing the second or the subsequent parts of this series. This is just section A. We are going to do the same thing for question 2, question 3, question 4, and question 5. All right, so let's move on to the next question. That's question 1H. Sorry, 1I, because this is G and this is H. So what is global warming? We have global warming every day, and we see the consequences of global warming all around us, like climate change, which is seen in form of famines, in form of flooding, and the rest of them. So what is this global warming? Global warming is a steady increase or a steady rise in the average air temperature of the world over a period of time. Global warming is a steady rise in the average air temperature of the world over a period of what? Time. What causes this global warming? Emission of what? Carbon dioxide and methane gases into the atmosphere, right? And the emission of carbon dioxide is mainly due to the combustion of fossil fuels, right? Combustion of fossil fuels and the burning of organic matter, like burning of bushes and the rest of them. Those are the things that release carbon dioxide into the atmosphere, right? This excess emission of carbon dioxide into the atmosphere leads to the trapping of the infrared rays or waves from the Earth's surface, right? And thereby overheating what the Earth was surface. So that's just a little bit of what global warming. Let's move on to the last question. State one cause of what? Global warming. Okay, like I've already explained. So what will be the one cause of global warming? You can say what? Excess what? Emission of what? Carbon dioxide gas into the what? Atmosphere, right? Due to the combustion or burning of fossil fuels. And examples of fossil fuels are your petroleum, coal, natural gas, right? Petroleum, for petrol you get your kerosene, petrol, diesel, all those fuels used for powering your vehicles and the rest of them, used for providing power in the industries, right? Most of them are what? Fossil fuels. So that brings us to the end of the first part of this series on the correction to the 2024 WAEC Chemistry Theory, right? If you're able to learn anything, don't forget to hit the like button, right? And ensure you subscribe to this channel and turn on your notification bell to stay updated with our other uploads. So until we come your way next time, I remain the Science Chef. Thank you and God bless.